OpenFOAM, that is foamListTime, foamCloneCase, and foamCleanPolyMesh. These are the three utilities which I am going to demonstrate today. Here I will consider one tutorial case which I'm going to demonstrate by using three utilities. First, foamListTime. What it does when we have the list of time directory in our case, so we can remove it. We will see in later on in the detail. Another utility, foamCleanPolyMesh. It will delete the mesh file from the case. It will delete mesh file from the case. Basically it is used when we are generating complex maths for the system. So, and we are using the snappy hash utility for generating the mesh. In that case we have to remove the existing mesh before running this snappy hash mesh. So we will see the later. And third utility is foamCloneCase, which is it creates a new case. It creates a new case by copying zero directory, system directory, and constant directory from a existing case. So we can create the new case by using this foamCloneCase utility. So let's watch in more detail. So and just let me open the terminal here. So today I'm going to use the community version OpenFOAM 8. So first as I can use this run command. So basically it's no, I have run the command where I have not sourced the OpenFOAM here. That's what is showing error here. What I'll do, see as we see, I just type OF. Basically it will display see what is this here. It belongs to OF. Basically in my machine there are several versions of OpenFOAMs are installed. As we can see that these are the and latest also this is the latest version. As ESI latest version also is there, and we have the latest version of community. Yes, see OpenFOAM 9 version 9, and we have the developer version also, OpenFOAM develop version. Now today we can select one of them and I can demonstrate. Today I'm going to select this one for this demonstration. I have sourced the OpenFOAM 8 which I have which is installed in my machine. So now let me clear the screen now. So we can type this run command. So so we can directly go into the run directory. There is another option. We can go to this OpenFOAM and run. Basically this is the foam run is the environmental variable, and we can see this. If you do this, it will display the path. Okay, where is my run directory. So now I'm going to, so I'm just going what we have in this directory. And first let me display this tree L2 label, and we don't have ls. See, we don't have the any case case here. Only I have the solver directory, which I have some solver in this solver directory. Now we don't have any case. Now let me copy some tutorial case. How we can copy the tutorial case? You can just type 2, then it will take you the where the OpenFOAM is installed. As we can see in the path, OpenFOAM install. These are the tutorial case. Yeah. So now I cd I'm going to this run directory. I want to copy one tutorial case from this tutorial directory, which is installed in the my machine. Where is it installed? Then tutorials are here. So now I'm copying one tutorial case. Next this we have to define this path. Open foam it, then tutorial case, tutorial, and we have, if you pressable, a simple form. We have the simple form solver is there, simple solver. So then we can see how there are some several tutorial are there. I'm just copying one of them. Like we can copy this p to the, yes, this, and I'm copying it into this my run directory. And we can see here, see, I'm just naming this test case for this tutorial. And then how we can do mbp, and we can give the name case, simple case, just whatever you want. We can give the name of this, say. So let me see. See, now we have the one case. So I'm going to demonstrate one case here, which is name is case. Let me go into the directory, case, see, and let me see what inside this, in the directory, add to label. So they but first we can visualize this ls. So there is a three directory. One directory 0, which is contain the initial field, fields, 0 time directory, and this is basically this is constant, which has the properties, and system here the system mean which scheme and schemes and control directory. Let me visualize this from this. So, and when we see this trees, we can see what inside the 0 directory. It will show that how many directory and files in this case folder, case directory. So these are the basically this case, this is the study case, steady state case in compressible flow analysis, and we are using this as foam. So simple form, basically this is a steady state problem, a steady state case. So now our motto is demonstrate that these three utility how we can use. Now first let me just, we can see how which command we are going to, and just either there are, as we most of us we know, there are two way to run the case in OpenFOAM. One, either you can give the one way is the interactive way, another way is scripting way. So like we can see this all, that is the all run is a script. It contains all the commands which we are going to use. So here we like we can get the application. So what application we are going to use here? Application, basically here we have the block mesh as snappy hex. Basically this is for application which solver we are going to use. In this problem we are using the simple form. So let me go out from here. Yes, so there, and we can remove, we don't need, because it's not a complex and we are complex problem. Just is a simple to demonstration this case. Even we can remove this, we don't require this. Remove. Yes, I can remove. Then we can see only we have the ls, only we have the three time directory. Now we can first what we have to create the mesh. So block mesh, what it does, it will create the mesh. If you execute, it will create the mesh. Now mesh. So how we can see tree and L, and if you put the 3 level up, so you can see the mesh file is here. So mesh is created now. Now next we can go, we can see bi system control date. You can see here that we are using the simple form, basically steady state solver, and we are using the, like we can see the OpenFOAM community version is the version 8. So basically, just let me go out. I'm not going to change anything, just I'm running this case. Simple, we have to go simple okay, foam. Just we can run this by default case. Let and um, yeah, and we can see tree, tree minus capital L and 3 label, or we don't require 3 label. Now I have already shown the mesh file. We can go the 2 label. We also we not need we can see the 1 label. This is the basic display, the way we can see the inside the directory, what file or what directory inside the directory. So we can see here there are there are 3 these are the several time directories are created. If we want to see the results here, so foam para foam and minus touch, it will create the dummy file, and over this either here para there are two ways to run there are two ways to visualize the results, and let me show one by one. First I will show the simple interactive simple one way. Just type para foam, it will open the para view, and we can see the results here. This one, yeah, this we can see a just 1 second. If we want to see the results here, how the velocity change, velocity profile, just 1 second. Yes, we can see the, and if you want to see the this yeah, just 1 second, we can see the iteration wise. Then if we run the we can, so it's very slow actually at this basically is not time, basically this is iteration, because it is the iteration case, because it is the steady state simulation. So how after 0 iteration we have like this, we don't have any velocity velocity profile, velocity field in our domain. So as we can see the 0 everywhere. When iteration happen after 100 iteration, the velocity profile develop velocity profile in the domain, we can see how the velocity profile inside our uh, domain, our in our domain. See here, and after 200 iteration, what is the velocity, and after 287 iteration, basically this profile is just this the one way we can see this open this para view. Another way para view, and we have some case, and we can put dollar, it will run the para view in the background mode, and see just background, just you can see the same, you can do the same thing both, which it depend upon your comfort level. So there are two way we can open. Now what is the difference here? Like in this case, my para view is running in the background, right? We don't require, when earlier case, that's when I stop here, that para view also stop. Yes, now this is the demonstration. Now then we have the like tree minus L2 see no L1. So, and we can see this we can see these are the basically the iteration directory, because this is steady state. So after 100 iteration, 200 iteration, what is the velocity profile? Now our now I'm going to the main I'm going to use the one utility here, how we can use, as I said, there is a form there is a first I'll use form list time, form list time. If you enter here, it will display the this directories, how many directories are there, see, and you can see here if display. Now I want to use this, I want to remove this, because when suppose when we use this, see timeless geometry. Suppose we have changed the settings, so and we have run the simulation again, it will overwrite. So then we can remove, this is better, we can remove the existing direct time directory or iteration directory trees from the from the open page current case, which we are basically, case mean your column which you are going to, basically that is the current case. Like we can say that this is your case, whatever column you can define your name whatever you want, xyz. So then now I'm going to use this remove rm, this rn option. Or if you want to see that help, just whatever, if you don't know, just help, type help, it will display all the information. I'm just like there is a case constant, all the information. Now I'm using this it will suppose I'm using this minus rm, so it will remove all the time directories. And it's depend on if you have the customized, you want to remove some customized time directly, then you can use time, then you define the range here. So that is the it will display all the information about the time list form list time house work. Now see, just one second, this we can see we have this. Now I'm going to use minus rm. What happens, you can see I use this, it will show saving directory one file. Now you can see, so there is no time, these direct, these 100 to 180, these are the directory has been removed. But see 3, see all the remove. But if you see this the mesh file, there is a mesh property or mesh file also, all mesh information is still there. See here in the whatever inside the polymesh folder directory, all the mesh information here, so which is exists now. All mesh file is nothing else, only the directory, this iteration or whatever you call this is steady state case, then we say the iteration directory has gone, or everything are same. Now this is the form list time is work. Okay, now next I'm going now, have you noticed here, see just one second, I'll show, these are the one this time I demonstrate this house work. Now my second option is theory. You can see these all mesh information is there, all mesh information there, right? So now what I'm going to do, I'm going to use some another utility which called foamCleanPolyMesh. So and you can see the difference. Now I'm using the second utility which I'm going to demonstrate today. Foam clean polymesh. Just we can enter here. So you can see here now the condition. Now have you seen here, previously we have seen the mesh information in the polymesh directory. So you can see here, but when we execute this, this foamCleanPolyMesh utility, the mesh information, or basically mesh, all the mesh mesh information have deleted from the polymesh folder. Basically this now, yeah, this is the second utility we can use here. If you want to see there, then you can see here, just go there and see, you can see just one second. What happened, just one second. So there is no just one second, this is skip time okay, because there is no time, is no mean it's not coming, because there is no information, that's what is not displaying here. There is no mesh in the our in the our this case directory. So because there is no mesh information, that's what is not displaying any mesh information here. Now check this one. These two usually I have done now. So let me just let me clean this what inside ls. Let me clean this cd, clean this tutorial case now. Foam clean clean tutorial basic form. If you execute this command, if you execute form clean tutorial, so if you see here, nothing is there, everything is clean now. So now I'm just I want to show one more thing here, just like block mesh I'm executing. If now let's see, you can see here now mesh information now here, right? And if you see all the mesh here, because we have created the mesh, so all mesh information are here, which we can visualize easily here, right? Yes. Now see, and this is the, and we can run the solver simple form. Yeah, so simple form. We can see, and we can see here there the some this the directory 100 iteration, because the iteration wise me why I'm calling basically this is a steady state, we don't have time here. This is if this is a steady state simulation, then we can say the time zero directory, time 100, time 100 second, time 200 second, time 87 seconds. So like that we can call, and we can see, we can visualize easily. Just we can see here the results also is there. So see, we can see the time, how the velocity profile velocity changing in our domain here. So these are basically, these are the two utilities I have done. One today's last which I'm going to demonstrate how, like just let me go 1 second, one one step back. So here, so this basically we have the existing case here, right? This one case. Now second the last one which I'm going to, how we can clone. Suppose how this, let me type which utility, form clone clone case. This utility form clone, basically this utility, what it does, this utility it basically when we have the, like when we have the existing case here, because this the system is a simple and this is the case is simple for, we have considered the simple case for to demonstration. When we have the complex complex problem, then we have the many files here and there are so many settings. So if you want to do some analysis, so you have some, if you change something, then you have the many cases here. So and which many cases mean many user specified input, like you can say you want to do some analysis where you have the some velocity, one case for velocity 1, case 2, velocity 2, velocity 3, velocity 4, case 4, like that. All the settings are same. Another week, for that then we don't require to set up again and again all cases. Just we can clone this case in the different. So after that you need to change the very limited values, like only you need to change the velocity v1 v1 to initially case 1 v1, for case 2 v2, just only that very few settings you need to change. These utilities, so how it work, let me show. First we have to give write this utility name, just name that case which we are going to clone. Just you are, suppose I am going to clone this case to case new. Just we can execute this. Yes, then what happens, see, it will display all the thing. It will copy, it will create the new case name and copy all the zero directory, constant directory into this new case. Let me so go to the c2 case new, and what have we can see here as, so we can see here all the uh, tree minus add to C. What happened? Oh, this is small. It should be capital. So we can see all the all zero directory, a constant directory, and system directory. We can say one more, and it will copy the mesh information, all the mesh information whatever in the previous case. So now we save the time. Now you see the how, what is the what is the most important advantage of this. We don't require to create the mesh for the another case. Just we can clone the, and we can define the we can change the some values, some values like initial earlier we used the v1 velocity. In this case you are using the velocity 2, so and you have the some another variable. So basically you can do the parameter. It will help to, it will help for the sensitivity analysis, like we can say. So yeah, hope, and if you want to see the results for this case, para view, just para foam open, then just see, because here we don't have result here, only suppose we have the mesh information, like we have not created mesh yet, but mesh information is there only. That is the main advantage, because most of the time and meshing is also generate the mesh also, it will take time. If we have the complex geometry, so we are using some yeah, like snappy hex mat utility, and then we have the another back to create the background mesh for the block mesh and all. So it will take some time to generate the mesh. So basically this is, we can save that our time which we spend to generate the mesh. So um, so what is the, what are the utility we have covered today. Let me just go back, just I'm just typing here which utility we have covered today. Form list and list time, this one. Like we have not defined anything, just because we don't have anything, that's what just enter. So this utility form list time, another utility form clean form clean polymesh. Second one is this, first time, the first utility is this, second is this, and third and form clone case, third utility this one. So if you don't anything about that, just you can take the help of utility. It will display the all information. These are the three utilities which we have covered today, today's demonstration. If you have any comment and suggestion, please write in the chat box. So I'll go through, then I will cover the more utilities for the coming next videos. So thank you for watching.